Now again, for this example, we have to see how many times hello is getting printed. So let us simply unfold these for loops. When value of I is equal to 1, my j will run from 1 to I. So my j will also run 1 time, and my k runs 100 times for each value of j. So when my j is 1, my k will run 100 times. When my I becomes 2, my j will run from 1 to 2, that is 2 times, and k will run for each value of j, k will run 100 times. So 100 times for this one, when j is 2, it will again run 100 times. So in total it is running 2 into 100 times. When my I becomes 3, my j will run from 1 to 3, that is 3 times, and for each value of j, my k will run 100 times each. So I can write my k is running 3 into 100 times. And so we can say when my I becomes n, my j will run from 1 to n, and for each value of j, my k will run 100 times. So I can say my value of k is running n into 100 times. Now if I add all these number of times my k is running, I will get the number of times hello is getting printed. So if I had 100 plus 2 into 100 plus 3 into 100 plus 4 into 100 and so on up to n into 100. If I take 100 common, I will get the series 1 plus 2 plus 3 plus up to n, and I can write this series as n into n plus 1 by 2 simply. Now to find big O analysis, we have to drop all the non-dominating terms. So I can write this as 100 into 100n square plus 100 into n divided by 2. So by dropping non-dominating terms, I drop this 100n, and by dropping constants, I drop this 102. So I am left with n square. So my time complexity finally is O of n square. So in this function, we have to see how many times hello is getting printed, and the number of times hello is getting printed is simply dependent upon the number of times these for loops are getting iterated. So we have to simply check how many times these for loops will iterate. When my I value is 1, my j will run from 1 to I square, and my I square is 1 again. So my j value will also be 1, and for each value of j, my k loop will run n by 2 times. So for each value of j, I will run it n by 2 times. When my I becomes 2, my j will run from 1 to I square, and my I square is 4. So my j will run 4 times, and for each value of j, my k function will run n by 2 times. So I can say in total my k function will run 4 into n by 2 times. So when my value of I is 3, it will run from 1 to 9, and I can directly write my k loop will run 9 into n by 2 times. This will go on up to n. When my I value is n, my j value is n square. So I can write directly that my last for loop will run n square into n by 2 times. So now we have to add. Now to check how many total times we will print hello, we have to simply add all of these. And by adding all of these, if I take n by 2 common, I get this series And what's so unique about this series is that it is sum of first n natural number square, and this series can be written as n by 2 n into n plus 1 2n plus 1 upon 6. I can solve it as n square n plus 1 2n plus 1 upon 12. We calculate time complexity, we simply ignore the non-dominating terms and we also drop the constants. And we are left with these 4n. So my final time complexity is O n to the power 4. So in this case, again we have to see how many times hello is getting printed. And for that we have to check these for loops. Now, my first for loop will simply run n times as I is getting incremented from 1 to n linearly. But in this j for loop, as this j value of j is dependent upon I, we have to unfold it. That is, we have to see case by case. So let's see. When my I is equal to 1, my j will also run from 1 to n. But in this case, I am having j equal to j plus I. That is j, it is simply increasing by a value of 1. So first my value of j is 1, then it is 2, and it is 3, and so on up to n. So it will also run n times. When my value of I becomes 2, again my j will run from 1 to n. But there is a difference now. j will become j equal to j plus 2. And when j equal to j plus 2, I will increment by a value of 2 to n. Now, total number of cases, these are, as you can see, we are having n by 2 cases as half of them are removed as we are increasing by a value of 2. When my I becomes 3, I will go from 1 to n and I will increment the value of j by a factor of 3. It will simply be up to n. Now if you see, the total number of times hello will get printed is not n by 2 but n by 3, because it is simply 1/3 of the total number of n's, as the number of n's are reduced. Similarly for 1, this is the last case I will tell you, 1 plus 5, 9, next will be 14 up to n, and the total number of cases is n by 4. Now we have to check for the last case n, it will again go from 1 to n. As you can see, now my j will become j equal to j plus I, and my I is equal to n. I will directly jump from 1 to n in one step, so I will only iterate one time, so I will have n by n. So I can say I will have n by n times. And now to find the total number of times my hello will get printed is simply adding all these values up to n by n. By taking n common, I have 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 up to 1 by n. And from mathematics, I can say directly this is the value of log n. Not exactly the value of log n, but this is in order of log n. Now most of you might be having a confusion why this value is log n. This is not log n exactly, but this is order of log n. Now there is a difference between exact value and order of log n. So I can say by combining with this n and this log n log n is my final complexity. So in this example, we again have to see how many times we are going to print hello. Let me write this as n equals 2 to the power 2 to the power k, and this j as j equals j square. Now let us see how many times we will print hello. Let us assume the value of k to be 1. This is our assumption. When my value of k is 1, my value of n equals 2 to the power 2 to the power 1, which is equal to 4. And when my n value is 4, my this for loop will run 4 times. It doesn't matter the value of n, it will always run n times. In this case, we have n value 4, it will run 4 times. When we have n equal to 16, it will run 16 times. Come and initialize j's value equals to 2, and we will come into this while loop. We will check whether j's value is less than equal to n, and we will j square. Then we will print hello, and again till we come out of this loop. So in total time we have printed hello is 2 times. This while loop printed hello total 2 times. And as we know, this while loop is nested in this for loop. So we simply multiply their complexities, n into 2 times. K value is equal to 2. So my n value becomes 2 to the power 2 to the power 2, which is equal to 2 to the power 4, which is equal to 16. Now j value will again initialize to 2, and we will square it till we get 16. So the total number of times we printed hello is 3 times, and this is the while loop which printed 3 times, and it is nested in for loop. So we will multiply their complexities, and this will become n into 3 times. Now let us take when my k becomes 3, my n will become 2 to the power 2 to the power 3, which is equal to 2 to the power 8, and my j value will go from 2, then it will become 2 squared, then it will become 2 to the power 4, and finally it will become 2 to the power 8. So the total number of time we printed hello is 4 times. Now the final moment when k value becomes k. This was our assumption that k value is 1, but in reality k value is equal to k. Now we can, at this moment we can see the pattern. When my k value is equal to 1, I am printing 2 times. When my k value is equal to 2, I am printing 3 times. When my k becomes 3, I am printing 4 times. So we can see the pattern. When my k is equal to k, we will print, this is n star, we will print n into k plus 1 times. So the total times we printed hello is n into k plus 1 times, and this is our complexity. Now we generally write complexity in terms of n, so we have to find k in terms of n, and we can find that from this relation. N is equal to 2 to the power 2 to the power k. Taking log on both sides, I can say log to the base 2 n is equal to log to the base 2 to the power 2 to the power k, and this value becomes 1, and this value comes in front of log by the property of log. So I can write log to the base 2 n is equal to 2 to the power k. Similarly, again taking log on both sides, I can write log n, which is equal to k. So my value of k is this. Now we can substitute this value of this. So my final complexity becomes n into log times n, and we discard non-dominating terms. So our final complexity is O n log n.